In this lesson, we're going to examine some three-dimensional problems and how we can use trigonometry to figure out some ideas there. So basically, this is just examples today in terms of there's no new math. We have to be able to apply our math, and the challenge here is going to be trying to draw that picture. Trying to visualize something in 3D can sometimes be difficult, especially when you're dealing on a 2D surface like a piece of paper or the screen here. So as reminders, we're going to be using SOHCAHTOA possibly. We're going to be using sine law. We're going to be using cosine law. We want to be able to use any of those tools to our advantage. So let's look at the first example. The figure shown below is a cube with side lengths of 12. The nice thing about cubes is when you know one side, you know all the sides. So they're all 12s. We want to find EG. So EG is a line. I know that because it only has two letters from E to G. So I think sometimes when dealing with three-dimensional things, it makes sense to redraw the triangle that you want to use. So what do I know? Well, I know EG is part of a right angle triangle. In particular, if I look at the ground, H is a corner, E is a corner, and G is a corner. And I know this is a right angle because it's a cube. Cubes are made up of squares. Squares have right angles in them. I also know that these two things are both the same length because it was a cube. They're both 12. So EG is here. I can find the third side of a right angle triangle fairly easily by using an old tool like Pythagoras. So in this case, I can write down that 12 squared plus 12 squared is x squared. And I don't need to use any fancy kind of math. I can use old stuff. So if I square them and add them, I get 288. That's x squared, don't forget. We need to square root it. And x comes out to 16.97. If I go to 3 sig figs, we can call that 17. Now, that wasn't too bad. Let's try part B. Part B asks us for angle. That's what this symbol means. Angle AGE. So again, that's part of a triangle. Now, the diagram has it, but it might be easier if I redraw it so I can see what I know and what I have. So A is up at the top, E is in the corner, and G is down here. And we know there's a right angle there. You can see it in the diagram. We also know, again, this is a cube. So A to E is 12. We just calculated E to G in the previous question. We figured this was 17. I want to find angle AGE. So if you recall, the letter in the middle is one that we really want. That's where our x happens to be. I can find this, it's a right angle triangle, by using SOHCAHTOA. We haven't done SOHCAHTOA in a couple days, really, so let's remind ourselves. In SOHCAHTOA, based on the angle that I have the opposite and the adjacent, which means I can use tan. So the tan of my angle is my opposite over my adjacent. If I want to solve this, it's an unknown angle, so I'm using an inverse of whatever 12 over 17 happens to be. And I get 16.3 to 3 sig figs. So let's look at the next example. A room is in the shape of a rectangular prism. Its floor measures 7.2 by 9.6, as the diagram shows, and the height is 3.5. Calculate the length of AC. So much like the previous question, this question is going to involve some right triangles. We know rectangular prisms have right angles in all the corners. So if I want to find AC, I can draw my diagram. I look at this and I say to myself, there's a right angle there, at angle B. Here's A, here's C. I know A to B is 7.2, C to B is 9.6. I want to find that. Well, it's sides again. That means I can use Pythagoras again. So I can do A squared plus B squared equals C squared. Okay, plug it in my calculator. I end up with 144 for x squared, which means x is 12. Done. And let's try the next one, AG. Where's AG in the diagram? Well, that one goes from the bottom corner all the way up to that top corner. So it's basically a slice through the diagram, if you will. Hard to see, but if I redraw it, I have A, I have C, and I have G. And I know A to C, I just figured that out, was 12. I know there's a right corner in the back of this, there's got to be a right corner here, right, where the floor meets the wall. And I know GC is the same height as it is over here, so that's 3.5. I want to find X again. Isn't that just another Pythagoras question? So I can do 12 squared A squared plus B squared equals C squared again. No big trick there. If I put those into my calculator, I get 156.25, and if I square root that one, I get 12.5. Okay, part C. Calculate the angle that AG makes with the floor. I already have a diagram that involves AG. That's this diagram right here. And where it hits the floor is actually this angle right here, angle A. I can figure out angle A by using SOHCAHTOA. I've got a right angle. In particular, if I use the opposite and the adjacent, I can use tan. So tan A equals opposite, 3.5, over adjacent, 12. I want to find an angle, so I'm going to use my inverse function, 3.5 over 12, and I got approximately 16.3 degrees. Okay, and that's kind of the things we can do here. Let's try one more example, these rectangular things. So given the following cuboid, a cuboid is just a fancy word for rectangular prism. Find the length of AG, BG, and then we'll find some angles. So AE. AE, there's a triangle, it's right angled. I've got A, B, and E. I know 12, I know 10. Oh, back to Pythagoras again. So 12 squared plus 10 squared is x squared. No real tricks there. 244 for x squared. Square root it, and you should get approximately 15.6. Okay, let's do, that was part one. Let's do part two. B to G. B to G. Where is B to G? B to G in this diagram goes from here up to the corner. Well, there's a triangle. So what do I got? I'm going to redraw this one. I got B, I got F, and I got G. What do I know? I know F to G is 4.5 for sure. It's the height of that thing. B to F. B to F. Well, isn't B to F the same as A to E? Isn't it the diagonal of the rectangle? So I actually know B to F is 15.6. What I need to figure out this time is B to G. But it's Pythagoras again. I've got a right angle triangle. So I can do A squared B squared equals C squared. If I put that into my calculator, and square them and add them, skip the work this time, the answer comes out to 16.3. We should be hopefully pretty good at Pythagoras by now. Okay, next thing. I want to find angle AEB. So let's talk about part B here. Angle AEB. And remember, it's the middle angle that's important. I actually have a diagram that involves these three letters already. It's right here, this diagram. So A to E to B means I want to find this angle up here. Well, that's a SOHCAHTOA question. It's right angled. This is my opposite. This is my adjacent. I can use tan. So I'm going to say that tan of E equals opposite over adjacent, which means I can use an inverse. And the inverse tan of 12 over 10 should come out to 50.1. Actually 1.9, so I should round that off. 2.2. 3 sig figs. Okay, last part. The angle between the plane ABEF, which is basically the floor, and the line AH. So I really want to find the angle that between this floor and that line. So the angle in the corner down here. Now, I kind of already know something. I know that angle is actually the same as this angle. Because the line that goes from B to G, the diagonal through the shape, is the same line that goes from A to H. They're the same length. They have to be. They're diagonals. Okay? So I kind of already have the diagram I need for this. I really need to find this angle. So to do part C, again, I can use a right angle triangle, SOHCAHTOA. Again, I have the opposite and the adjacent. So again, I can use tan. And even though I'm finding angle B, it's the same as angle A. They have to be the same. So 4.5 over 15.6. And we could use our inverse tan again. We should get 16.07, or in other words, 16.1 degrees. And the third example there we did with rectangular prisms. So last example, let's take a look at something that's not a rectangular prism. Let's look at a pyramid. So what do we have here? We have a square-based right pyramid. ABCD is a square of side 10. VX is the perpendicular height. In other words, it goes straight down the middle. It makes a right angle right there of 8 centimeters, and M is the midpoint of BC. So in other words, M is halfway along. This is 5 and this is 5. It's a square-based pyramid, right? Write down the length of XM. How far is it from here to there? Well, if X is in the middle and M is on the side, then XM has to be 5 centimeters, halfway. Calculate the length of VM. VM is the one that goes along the side. We call that our slant height. I can do that if I think about this as being a triangle. V up at the top, X down here, M over here. It's right angled. We knew this was 8 from the diagram. We figured this was 5. I got to figure out this unknown side. I can do that using Pythagoras. A squared plus B squared equals C squared, VM squared. So into our calculator we go. This comes out to 89 for VM squared, but I won't. Just the length of the VM. So you should get 3 sig figs, 9.43 centimeters. Last part. Find the angle between VM and ABCD. In other words, where does this line hit the surface? So the angle down here, which in our diagram is right here. Angle M, if you will. And good news, we're back to SOHCAHTOA. Back to tan in particular. The tan of M, because I have the opposite and the adjacent again. Okay, tan is a very handy tool. So we use our inverse tan of 8 over 5. If you do that, you should get 57.99, which is 3 sig figs, 58.0 degrees. And so there's some practices of three-dimensional things. Our homework today is a handout, and the answers are on it, so you can check things out. If you're stuck with some of these things, the hard part is trying to draw that picture sometimes. It's kind of hard to think in 3 dimensions when you have a 2-dimensional piece of paper. So if you get stuck, come see me and we'll figure some things out.